In lesson 2.5, we went over using inverse operations to solve problems that had addition and subtraction. Since addition, adding, and subtraction are inverse operations. So if we looked at these two examples, we'd be saying, okay, this is subtraction. We're going to add 25 to cancel them out and get a value of 0 to both sides, to isolate the variable f and get our answer. In this example, we're subtracting negatives, really taking away negatives. We could simplify that and write it as plus 7. This is still the same thing, so when we're trying to cancel out that positive 7, we're going to subtract 7 on both sides, giving us 25. We can always plug this number back in to the original equation to double check that we got it correct. Today what we're going to be focusing on is still using inverse operations, but with a focus of multiplication and division being our inverse operations. And this is what that will look like. We're going to be using the division property of equality, meaning if we divide on one side of the equal sign, we also need to divide on the other side of the equal sign. Whether it's arithmetic, meaning all numbers, or algebraic, if we're dividing by c on the left side of the equal sign, we also have to divide by the value c on the right side. It has to balance. So let's look at the first example. The United States population in 2005 was twice the population as it was in 1949. Find the 1949 population. Okay, so the population in 2005 was is just a past tense word for is, so that's our equal sign. So we know that the population in 2005 was equal to twice, meaning 2 multiplied by the population in 1945. Or excuse me, not 1949. Okay? Now, if we make it all numbers rather than what we have, we know, according to this image, that in 2005, our population was 296 million. So now we need to plug that into the correct place. In 2005, that's our first value, we need 296 million. Right now, everything is in millions, so we don't have to write down the number millions. We're just using 296 and knowing that our label is millions. 2 multiplied by, in this case, we don't know the population in 1949, so we're going to use a variable. I'm going to use the variable p for population. We can always note that as well. P is talking about the population. So then, we would need to solve. This is multiplication because they're right next to each other, so we're going to divide. We use a fraction bar line to show that division on both sides. That's division. 2 divided by 2 gives us 1, leaving us with 1p, which is exactly what we want. Whether we write it as 1p or just as p, it's still 1p. And then we would divide each of these numbers. So then again, top C in the box C, 296 divided by 2 goes in once. Bring down the 9, goes in 4 times, double check, and bring down the 6. So we know that we have 148 is equal to 1p, or just 148 is equal to p. Telling us that our population was 148, remember the label, million people in 1949. So that would be your answer, and we can always check to make sure that it worked by plugging it back in. So if we took 296 is equal to 2 multiplied by 148, this multiplication should give us exactly 296. So 148 times 2 which it does. So we know that yes, we did it correctly. And 148 million people would be the correct answer. So let's do a few examples. We're using division to solve the problems. So in this first example, we have 4x is equal to 84. So we know for both of them, I'm going to rewrite it, that we need to divide by 4 because right now it's being multiplied using inverse operations. So we use a fraction bar line to show the division on both sides, dividing by 4, and that'll give us x is equal to 8 divided by 4 is 2, 4 divided by 4 is 1. So our answer would be 21. If we look at the next example, we would do the exact same thing. It's being multiplied by 7, so we're going to say that we're going to divide by 7 on both sides. And when we divide by 7, that'll give us a 1 as our coefficient. So then we have 13 is equal to y for our answer. Again, we can plug that 13 back in to make sure that it works, doing 13 times 7. And then for our last one, 12w is equal to 108. We're going to show that we're dividing by 12 on both sides, because right now it's multiplied by 12. So using inverse operations and our property of equality on both sides of our equal sign. That'll give us a 1, 12 divided by 12 is 1, leaving us with just w is equal to, this time it's 9 for our answer. So that's using division to solve an equation. This next example is just using a negative value. So when we're working with this, we always want to double check that we are taking into account the signs. This is still multiplication, so we're going to divide by 5 on both sides. That'll cancel, giving us r is equal to, now it's a negative 20 divided by a positive 5, opposite sign, so it's going to be negative, and 20 divided by 5 is negative 4. We can plug that back in, saying 5 multiplied by negative 4. And in this case, yes, it does equal negative 20, so we have the correct answer. Let's just do a couple more of them. In this case, we're going to divide by negative 3, because this is multiplication, whether that sign is shown or not. If we divide by negative 3 on both sides, then we have b is equal to positive divided by negative gives us a negative, and 24 divided by negative 3 is negative 8. We have our answer again. All right, I think that is enough. If you wanted to give these two a try, you can, just to make sure that you are doing them correctly. I would recommend pausing the video before checking your answers. So for b, when we divided by negative 8, we got negative 12 is equal to n. And then for c, when we divided by negative 4, negative 56 divided by negative 4, same sign, so it gives us a positive 14. All right. Example number 3, switching over. Now we're going to be using multiplication to solve the equations, using our multiplication property of equality. Again, just saying what we do to one side. So if we're multiplying by 2 on one side of the equal sign, we also have to multiply by 2 on the other side. It has to balance. So if we're multiplying by c on the left side, we are also multiplying by c on the right side. And this is what it'll look like. When we have a problem that looks like a fraction, I want to remind you that this is also division. It's just another way of showing division. So the inverse operation of division is going to be to multiply. We show that by showing the multiplication in the numerator. Right now we're dividing by negative 9 because it's happening in the denominator. So we need to show that multiplication in the numerator. And it's important that that's in the numerator, because if it's in the denominator, then we're just saying that it's negative 9 times negative 9 in the denominator. And we don't want to be dividing by 81 like that would look like. We want it to cancel out. So multiplying by the negative 9 has to happen in the numerator. If we show it on one side, we also have to show it on the other side of our equal sign. So now when we simplify this, negative 9 divided by negative 9 cancels out and gives us a positive 1x. and then we would simplify on the other side, giving us a positive 27. We can write that final answer as x is equal to 27, both of which are good answers. This one would be better. So if we do a couple more examples, again, we talked about right now r is being divided by -5 because the -5 is in the denominator. So to cancel out dividing, we need to show that multiplication in the numerator. So on top of the fraction, and then balance it on both sides, multiplying to the right side of the equal sign as well. Balancing our operations. -5 divided by -5 gives us a positive 1, so right now it's canceled and it's just r. And then we simplify, giving us a -50. Again, we can always plug it back in to make sure we did it correctly. So then we would have -50 divided by -5, and that should equal 10. Well, we know a negative divided by negative is a positive, and 50 divided by 5 is 10. So we got the correct answer. Alright, why don't you give the next two a try? I would recommend pausing the video before going forward and seeing the answers. Alright, so if we look at B, we were dividing by 6, so we showed the multiplication in the numerator. 6s divided by 6 is just going to give us s, and then when we balance it on both sides, we get 324. For C, we're dividing by a positive 20, so we're going to multiply in the numerator by a positive 20 on the right side and also balance that with the left side, leaving us with just t on the right side. Notice the variable goes straight down, staying on the same side of the equal sign, and then when we simplify, we get -600 is equal to t. So when you're working on each of these, you want to make sure that you're double checking using the correct inverse operation and always double checking your sign to make sure that you're doing it correctly.